Between 1939 and 1944, German industrial capacity produced over 130,000 Opel Blitz trucks, creating the most reliable logistics backbone in the European theater. The vehicle's robust 3.6-liter engine, interchangeable parts compatibility, and proven chassis design enabled Wehrmacht supply operations to function across vast distances with unprecedented efficiency. Standard doctrine assumed that rapid territorial acquisition would provide access to fuel depots, maintenance facilities, and replacement components within captured zones. The truck performed exactly as specified, maintaining operational readiness across extreme terrain while supporting advance rates that exceeded all historical precedents. Yet this same reliability enabled a fundamental strategic miscalculation. Military planning embedded the assumption that logistics capacity should match offensive capability, not constrain it. The Blitz's dependability allowed commanders to commit forces far beyond sustainable supply perimeters, trusting that the vehicle fleet could bridge any temporary gap. When campaigns extended beyond the truck's maximum operational radius and captured infrastructure proved inadequate or destroyed, the system faced an irreversible constraint. The vehicles that had enabled unprecedented mobility became immobilized assets scattered across territories too distant to supply or retrieve. This is not an analysis of tactical decisions or strategic failures. It is an examination of how engineering excellence can embed assumptions that make operational disaster structurally inevitable. How can a logistics system's greatest strength guarantee its own collapse? The Opel Blitz represented a convergence of American automotive engineering principles and German industrial capacity that fundamentally altered military logistics doctrine. When General Motors acquired Opel in 1929, the production infrastructure and engineering philosophy of mass manufacturing crossed into European military planning at a critical historical moment. The truck that emerged from this technological transfer embodied assumptions about operational sustainability that would prove both enabling and catastrophic. The foundation of the Blitz design rested on component interchangeability and mechanical robustness, derived directly from General Motors' commercial vehicle architecture. The heavier models utilized the flathead 61 PS 3.5-liter petrol straight-six engine from the 1930 GM Marquette, while Opel's own 2.6-liter four-cylinder engine powered lighter variants. This dual-engine strategy reflected a core design philosophy: standardization without operational constraint. By 1934, the product line had expanded to encompass 4 versions of the 1-ton basic model and 14 variants of 2-ton and 21/2-ton configurations, creating a modular logistics platform that could theoretically support any military requirement. The engineering significance of this approach extended beyond mere vehicle performance. The Blitz embodied the principle that logistics capacity should be scalable and adaptable rather than mission-specific. Unlike previous military transport systems that were purpose-built for defined operational parameters, the Blitz was designed as a universal platform. This universality was achieved through mechanical simplicity and parts commonality. The overhead valve 75 HP straight-six engine introduced in 1937, shared with Opel Admiral passenger cars, exemplified this philosophy. The engine was sufficiently similar to contemporary Chevrolet power plants that advancing Allied forces could restore abandoned German vehicles using standard American and British components. This design decision revealed the first critical assumption embedded within the system: that mechanical reliability and parts availability were equivalent to operational sustainability. The engineering logic was sound within civilian commercial applications, where service networks and supply chains operated within established geographic and economic frameworks. Military operations, however, imposed fundamentally different constraints on the relationship between vehicle capability and logistical support infrastructure. The Wehrmacht's adoption of the Blitz as its primary logistics platform represented a doctrinal shift toward mobility-centric warfare that assumed logistics could be engineered to match tactical requirements. Beginning in 1939, the Blitz 3.6 3-ton version became the standard medium transport vehicle across all German armed forces. The production numbers reflected this strategic commitment. Over 130,000 vehicles and chassis manufactured between 1935 and 1944 at the Brandenburg facility alone. This scale of production created a logistics ecosystem entirely dependent on the continued availability of fuel, spare parts, and maintenance infrastructure within operational theaters. The design's mechanical sophistication masked a fundamental vulnerability in its operational assumptions. The Blitz's reliability enabled commanders to commit forces at distances that exceeded sustainable supply chain capacity. Unlike rail-based logistics systems, which imposed inherent constraints on operational range through fixed infrastructure requirements, truck-based mobility appeared to offer unlimited geographic flexibility. The vehicle's proven performance across varied terrain conditions reinforced the illusion that logistics capacity could expand indefinitely to match tactical ambitions. The half-tracked Multi-A variant, utilizing Panzer I tank tracks and suspension, demonstrated how engineering solutions could temporarily overcome environmental constraints while amplifying systemic vulnerabilities. This adaptation enabled operations in Rasputitsa mud conditions on the Eastern Front that would have immobilized conventional wheeled vehicles. However, the increased mechanical complexity and specialized component requirements created additional dependencies on supply chain continuity. Each engineering enhancement that extended operational capability simultaneously increased the system's susceptibility to supply disruption. The control architecture of Wehrmacht logistics operations reflected civilian automotive assumptions about resource availability and infrastructure continuity. Military planners assumed that captured territories would provide access to fuel refineries, maintenance facilities, and component manufacturing capabilities. This assumption was embedded in operational doctrine that prioritized territorial acquisition over supply line consolidation. The Blitz's mechanical reliability appeared to validate this approach during initial campaigns where rapid advances secured resource bases before supply constraints could develop. The instrumentation of logistics operations relied on traditional military metrics: vehicles operational, fuel consumption rates, maintenance intervals, that provided accurate measurement of immediate system status while concealing fundamental supply chain dynamics. Commanders could observe that truck fleets maintained operational readiness across extended distances without understanding the cumulative depletion of support infrastructure required to sustain that readiness. The apparent independence of vehicle performance from supply chain constraints created a false operational picture that influenced strategic decision-making. Two critical design assumptions became invalid under extended operational conditions. First, the assumption that mechanical reliability translated directly to operational sustainability ignored the exponential relationship between supply line length and resource requirements. Each kilometer of advance required geometric increases in fuel consumption for supply transport, creating an invisible constraint that vehicle performance metrics could not detect. Second, the assumption that captured infrastructure could substitute for organic supply capacity overlooked the deliberate destruction policies employed by retreating forces and the time required to restore damaged industrial facilities. The difference between indication fidelity and diagnostic validity became apparent only when supply chains stretched beyond their elastic limits. Vehicle readiness reports provided accurate measurements of immediate mechanical status while failing to convey the cumulative degradation of the support system required to maintain that status. Fuel consumption data recorded current usage patterns without projecting future availability constraints. Maintenance schedules tracked component replacement requirements without accounting for declining parts inventory across extended supply networks. These measurement limitations created a systematic bias toward optimistic operational assessments. The Blitz's demonstrated reliability across diverse terrain and weather conditions reinforced confidence in the sustainability of extended campaigns. Each successful advance validated the assumption that logistics capacity could expand to match tactical requirements. The vehicle's performance provided tangible evidence that mobility-based warfare could overcome traditional constraints on operational range and tempo. The vulnerability inherent in this operational model remained hidden until supply lines reached their maximum sustainable extension. At that point, the same mechanical reliability that had enabled unprecedented territorial gains became a liability. Vehicles that had advanced beyond the reach of sustainable supply chains could neither retreat efficiently nor maintain operational readiness in forward positions. The engineering excellence that had made rapid expansion possible simultaneously created the conditions for comprehensive logistics failure. The Opel Blitz system embodied the fundamental contradiction between tactical capability and strategic sustainability that would define the collapse of German military operations across multiple theaters. The vehicle's design enabled operational patterns that exceeded the carrying capacity of the supply infrastructure required to support those patterns. The organizational structure that governed Blitz production and deployment contained multiple latent failures that aligned to create predictable decision-making pathways toward operational disaster. These failures manifested not as dramatic breakdowns, but as systematic biases embedded within planning processes, training doctrines, and resource allocation mechanisms that made catastrophic overextension appear rational to decision-makers at every level. The production infrastructure established at Brandenburg in 1935 reflected Nazi economic mobilization principles that prioritized quantity over sustainability considerations. The facility's design emphasized maximum output rather than flexible response to changing operational requirements or resource constraints. This approach created a manufacturing system capable of producing over 130,000 vehicles in less than a decade, but structurally incapable of adapting production to match actual supply chain capacity in operational theaters. The commitment to high-volume production created institutional momentum that drove continued vehicle deployment regardless of logistics sustainability. Maintenance configuration practices within Wehrmacht motor pools revealed systematic verification gaps that amplified the disconnect between reported vehicle readiness and actual operational capability. Standard procedures emphasized mechanical functionality assessment while minimizing comprehensive supply chain impact analysis. Vehicle inspection protocols focused on immediate operational status, engine performance, transmission function, brake effectiveness, without requiring assessment of parts availability, fuel reserves, or maintenance support infrastructure within the operational area. This verification bias created a systematic overestimation of sustained operational capacity. The maintenance tagging and documentation system exemplified how administrative efficiency could mask operational vulnerabilities. Vehicles were classified as operationally ready based on mechanical condition assessments that did not account for supply chain dependencies. A truck that passed all mechanical inspections could be classified as mission-capable, even if replacement parts, fuel supplies, or qualified maintenance personnel were unavailable within the operational theater. This classification system provided commanders with vehicle availability data that was technically accurate but operationally misleading. Training doctrine for logistics officers reflected peacetime assumptions about resource availability and infrastructure continuity that proved catastrophically inadequate under extended campaign conditions. Officer education emphasized tactical mobility and efficient resource utilization without adequate preparation for supply chain failure scenarios. Training exercises simulated operations within established infrastructure networks that provided predictable access to fuel, parts, and maintenance facilities. The curriculum did not adequately address scenarios where advancing forces would operate beyond the reach of organic supply capabilities for extended periods. The training emphasis on tactical flexibility inadvertently created strategic inflexibility by reinforcing the assumption that operational problems could be solved through enhanced mobility rather than supply chain consolidation. Officers were trained to overcome immediate obstacles through rapid maneuvering and resourceful improvisation, skills that proved effective during short-term operations but counterproductive during sustained campaigns. This training bias encouraged commanders to view supply chain constraints as temporary impediments to be bypassed, rather than fundamental limitations requiring operational adjustment. Human factors analysis of Wehrmacht command decision-making reveals systematic cognitive traps that made overextension appear strategically sound. The availability heuristic led commanders to overweight recent successful experiences with rapid advances while underestimating the cumulative resource costs of extended operations. Early campaign successes, enabled by Blitz reliability across varied terrain, created confidence in the sustainability of mobility-based warfare that persisted even as supply indicators began showing stress. The confirmation bias inherent in military reporting structures systematically filtered negative supply chain information while amplifying positive tactical outcomes. Field commanders, trained to emphasize mission accomplishment and tactical success, naturally focused reporting on territorial gains and enemy defeats rather than declining supply margins and logistics vulnerabilities. This reporting bias created an institutional feedback loop that reinforced optimistic operational assessments while obscuring emerging sustainability crises. Organizational factors that influenced decision-making pace and confidence created additional vulnerabilities within the logistics management system. The Wehrmacht's command culture emphasized rapid decision-making and aggressive exploitation of tactical opportunities, values that proved effective during initial campaign phases but catastrophic when applied to supply chain management. The institutional preference for speed over deliberation discouraged the detailed analysis required to assess long-term logistics sustainability. The alarm system design within Wehrmacht logistics command structures suffered from critical prioritization failures that prevented effective crisis recognition. Supply reports were structured to emphasize immediate operational capabilities rather than trend analysis or sustainability projections. Fuel consumption data was reported as current usage rates without analysis of remaining reserves or resupply timelines. Maintenance requirements were communicated as immediate needs rather than cumulative degradation patterns that could predict future system failures. These reporting limitations created a systematic delay in crisis recognition that prevented effective corrective action. By the time supply shortages became apparent in operational reports, the underlying causes, overextended supply lines, insufficient organic transport capacity, declining captured resource yields, had already created irreversible constraints on tactical flexibility. The information architecture provided early warning indicators that were accurate but insufficiently integrated to enable predictive analysis. Procedural bias within logistics planning reflected the assumption that supply capacity could be scaled to match tactical requirements rather than acknowledging supply constraints as operational limits. Planning doctrine emphasized mission accomplishment through resource optimization rather than mission modification based on supply limitations. This approach encouraged commanders to view logistics as a support function that should adapt to tactical decisions rather than a constraint that should influence tactical planning. The procedural emphasis on resource conservation created additional cognitive traps that amplified overextension risks. Conservation measures, rationing fuel, extending maintenance intervals, reducing supply margins, appeared to extend operational capacity while actually reducing system resilience. These measures enabled continued operations under increasingly marginal conditions while masking the fundamental unsustainability of the overall operational pattern. Quality control processes within the supply chain management system suffered from verification gaps that prevented accurate assessment of system-wide logistics health. Individual components, vehicle readiness, fuel availability, parts inventory, were monitored and reported separately without systematic integration that could reveal emerging systemic vulnerabilities. This compartmentalized approach to logistics monitoring created an illusion of system control while obscuring critical interdependencies. The organizational structure that governed supply chain decision-making reflected hierarchical biases that systematically distorted information flow and decision authority. Strategic planning occurred at command levels that lacked detailed knowledge of tactical supply realities, while tactical commanders lacked authority to make strategic adjustments based on supply constraints. This structural disconnect created systematic delays in adapting operational plans to match supply realities. Prior similar events within Wehrmacht operations provided clear warnings about the risks of extended supply lines, but these lessons were inadequately integrated into planning doctrine. The Spanish Civil War had demonstrated the challenges of maintaining mechanized operations across extended territories, but these experiences were dismissed as irrelevant to the improved capabilities provided by Blitz mobility. This institutional failure to learn from analogous situations reflected cognitive biases that prioritized technological optimism over historical analysis. The latent failure theory framework reveals how these seemingly minor organizational weaknesses align to create systematic decision-making pathways toward operational disaster. Each individual bias or limitation appeared manageable within its immediate context, but their cumulative effect created institutional momentum toward unsustainable operational patterns. The organizational system was designed to optimize for tactical success without adequate consideration of strategic sustainability constraints. The human-machine interface mismatch between logistics planning systems and operational reality created systematic misunderstanding of supply chain dynamics. Planning tools provided data about immediate resource availability without adequate modeling of consumption trends or resupply constraints under extended operational conditions. This interface design encouraged planning assumptions that were mathematically precise but operationally unrealistic. The transition from initial campaign success to supply chain crisis occurred through a predictable progression of decision-making errors enabled by these latent organizational failures. The same institutional structures and cognitive biases that had enabled rapid early advances prevented effective recognition and response to emerging sustainability constraints. The divergence between operational capability and supply chain reality began not with dramatic shortage announcements, but with the routine success of Operation Barbarossa's opening phases in June 1941. The Wehrmacht's initial advance rates exceeded all historical precedents for mechanized warfare, creating confidence in logistics doctrine precisely when supply chain fundamentals were beginning to degrade beyond sustainable limits. The Blitz fleet performed exactly as designed during this critical period, maintaining operational readiness across advancing fronts while concealing the exponential growth in supply line extension that would soon exceed system capacity. During the first week of operations, German armored spearheads advanced over 400 kilometers into Soviet territory, supported by Blitz convoys that maintained fuel delivery schedules despite rapidly expanding supply distances. Vehicle readiness reports indicated 85 to 90% operational availability across motor transport units, figures that matched peacetime training exercise standards. Fuel consumption tracking showed usage patterns within predicted ranges for high-tempo operations. These indicators suggested that logistics performance was matching tactical success, validating pre-war assumptions about the scalability of truck-based supply systems. The first moment of divergence between perceived and actual system status occurred when supply line calculations began incorporating the geometric relationship between advance distance and transport capacity requirements. Each kilometer of territorial gain required approximately 2.2 kilometers of additional round-trip transport distance for supply convoys, accounting for route inefficiencies, security requirements, and return journey fuel consumption. This relationship remained invisible in daily logistics reports, which focused on immediate delivery success rates rather than cumulative transport burden analysis. Automatic system responses within Wehrmacht logistics initially functioned as designed, masking the developing crisis through procedural adaptations that appeared to maintain operational effectiveness. Fuel rationing protocols reduced consumption rates without immediately impacting tactical capabilities. Maintenance interval extensions preserved parts inventory while maintaining vehicle availability. Supply convoy consolidation improved transport efficiency while reducing delivery frequency. Each adaptation maintained the appearance of system control while actually reducing operational resilience. The expected behavior pattern for extended mechanized operations assumed that captured Soviet infrastructure would provide substitute supply capacity that could offset growing transport requirements. Intelligence assessments projected that seized fuel depots, rail networks, and industrial facilities would contribute to Wehrmacht's supply capacity within occupied territories. Initial captures appeared to validate these projections, with significant fuel stocks and transportation assets falling under German control during rapid territorial advances. Observed behavior in the control architecture of Wehrmacht Logistics Command differed subtly but critically from expected patterns. Supply officers reported successful adaptation to extended operations through efficiency improvements and resource optimization measures. Vehicle availability remained within acceptable parameters despite increasing maintenance challenges. Fuel delivery schedules were maintained through convoy optimization and route improvement. These reports suggested successful logistics adaptation while concealing fundamental capacity degradation. The systematic measurement comparison between logistics indicators and actual supply chain status revealed the first clear evidence of developing crisis. Wehrmacht's supply doctrine assumed a linear relationship between territorial control and resource availability, but actual captured infrastructure provided minimal net supply contribution. Soviet scorched earth policies had systematically destroyed fuel stocks, transportation equipment, and industrial facilities before German forces could secure them. Road and rail networks suffered extensive damage that required significant reconstruction resources. Meanwhile, German supply requirements grew exponentially with territorial expansion. Fuel consumption for supply transport increased geometrically as convoy distances extended. Security requirements for supply route protection diverted combat units from tactical operations. Maintenance demands escalated as vehicles operated under continuous high-stress conditions across difficult terrain. The cumulative effect created resource consumption patterns that exceeded even optimistic projections for captured resource yields. The instrumentation available to Wehrmacht logistics commanders provided accurate tactical information while systematically obscuring strategic supply chain dynamics. Daily fuel delivery reports confirmed successful supply operations without analyzing consumption trends or remaining reserve capacity. Vehicle readiness statistics tracked immediate operational availability without projecting maintenance sustainability under extended operations. Personnel reports monitored current strength levels without modeling attrition patterns or replacement capacity. This instrumentation design created a systematic lag between actual supply chain degradation and command recognition of developing crisis. The measurement framework was optimized to support tactical decision-making rather than strategic supply chain management, creating blind spots that prevented early warning of approaching sustainability limits. Commanders could observe successful daily operations without understanding that these operations were depleting system capacity at unsustainable rates. The physics of supply chain dynamics imposed constraints that became invisible until capacity limits were approached. Transport efficiency decreased exponentially with distance due to fuel consumption for empty return journeys, security requirements that reduced effective cargo capacity, and route circuity that increased actual travel distances beyond direct geographic measurements. Vehicle maintenance requirements increased due to continuous operation under field conditions, extended maintenance intervals, and limited parts availability in forward areas. These physical constraints operated independently of tactical success or organizational efficiency. Even optimal logistics management could not overcome the fundamental mathematics of extended supply lines operating beyond sustainable capacity limits. The Wehrmacht's institutional focus on tactical optimization prevented recognition that the operational problem required strategic adjustment rather than efficiency improvement. The decision fork where commanders faced competing interpretations of supply chain status emerged gradually, rather than as a discrete crisis moment. Field commanders observed continued tactical success and maintained vehicle availability, indicating successful adaptation to extended operations. Supply officers reported growing challenges, but continued mission accomplishment through resource optimization and procedural adaptation. Intelligence assessments suggested that captured resources would eventually contribute to supply capacity as occupied territories were consolidated. These competing indicators created ambiguity about actual supply chain status that enabled continued optimistic assessment. The absence of immediate crisis allowed commanders to maintain confidence in logistics doctrine, while cumulative degradation continued below the threshold of crisis recognition. Each successful daily operation reinforced the assumption that supply challenges represented temporary adjustment problems rather than fundamental sustainability constraints. The transition point where tactical success began to mask strategic vulnerability occurred when advance rates exceeded the Wehrmacht's ability to consolidate captured territory and infrastructure. Rapid territorial gains created an illusion of strategic success while actually increasing supply chain vulnerability through geographic overextension. The Blitz fleet's proven reliability enabled these advances while concealing the cumulative resource depletion required to maintain extended operations. By August 1941, German forces had advanced over 1,000 kilometers into Soviet territory across multiple fronts, creating supply line extensions that required exponentially increasing transport capacity. Fuel consumption for supply operations began approaching total delivery capacity, creating zero-margin operations that eliminated any reserve capacity for crisis response. Vehicle maintenance requirements increased beyond field capacity, creating a growing backlog of deferred maintenance that threatened future operational availability. The apparent stability of tactical operations during this period concealed approaching systemic breakdown. Unit commanders continued to report successful mission accomplishment while actually operating under increasingly marginal conditions. The Wehrmacht's institutional emphasis on tactical success prevented recognition that continued operations were creating irreversible degradation in strategic capacity. The measurement systems that had enabled initial success became obstacles to crisis recognition as supply chain fundamentals approached collapse. The mathematical foundations of Wehrmacht logistics failure became apparent through analysis of transport capacity degradation under geometric supply line extension. The relationship between territorial advance and supply requirements followed predictable physical laws that German planning doctrine systematically underestimated. Each kilometer of advance required exponential increases in transport capacity that eventually exceeded the Wehrmacht's ability to maintain operational sustainability, regardless of tactical efficiency or resource optimization. The physics autopsy reveals that supply line failure initiated when transport requirements for fuel delivery began approaching total transport capacity. At distances exceeding 800 kilometers from supply bases, approximately 40% of delivered fuel was consumed during the transport process itself, including return journey requirements and security convoy overhead. This consumption ratio created accelerating degradation in net supply capacity that could not be offset through efficiency improvements or captured resource integration, not vehicle. Utilization analysis demonstrates the feedback loop that transformed tactical success into strategic liability. High-tempo operations required continuous vehicle operation beyond design duty cycles, creating accelerated maintenance requirements that consumed increasingly limited parts inventory. Extended maintenance intervals, implemented to preserve parts availability, created cumulative mechanical degradation that reduced vehicle reliability and increased breakdown rates. The resulting maintenance backlog consumed transport capacity that could otherwise deliver operational supplies. The two-phase flow dynamics of Wehrmacht supply operations created measurement distortions that concealed approaching crisis until breakdown became inevitable. Forward area fuel storage operated near capacity limits to minimize transport requirements, creating inventory systems with minimal reserve margins. Small disruptions in delivery schedules created immediate shortages that required emergency resupply operations, consuming additional transport capacity while reducing operational flexibility. These emergency operations appeared successful while actually accelerating overall system degradation. Nat mass balance calculations reveal the fundamental unsustainability of extended Wehrmacht operations by late 1941. Daily fuel consumption requirements across all fronts approached 24,000 tons, while maximum delivery capacity from German supply bases totaled approximately 18,000 tons under optimal conditions. The 6,000-ton daily shortfall was initially covered through captured stocks and reduced operational tempo, but these temporary measures masked accelerating inventory depletion that would soon eliminate all operational reserves. The indicator analysis shows how Wehrmacht logistics instruments provided accurate immediate data while failing to convey approaching systemic failure. Fuel delivery reports tracked successful transport operations without analyzing consumption trends or reserve depletion patterns. Vehicle availability statistics monitored current operational readiness without projecting maintenance sustainability under extended high-stress operations. Personnel strength reports confirmed adequate manning levels without modeling attrition rates or replacement capacity limitations. These measurement limitations created systematic diagnostic errors that influenced command decision-making throughout the critical period. Commanders observed continued tactical success and maintained supply delivery, interpreting these indicators as evidence of successful adaptation to extended operations. The instrumentation framework was designed for tactical optimization rather than strategic sustainability analysis, creating blind spots that prevented recognition of approaching capacity exhaustion. The point of no return for Wehrmacht supply operations occurred when daily consumption requirements permanently exceeded sustainable delivery capacity. This threshold was reached in different sectors at different times, creating a rolling collapse that appeared as isolated local difficulties rather than systemic failure. The Army Group Center reached sustainability limits in early September 1941, followed by Army Group South in October and Army Group North in November. The staggered timing of these breakdowns obscured their common cause in supply line overextension. Thermal analysis of vehicle operations reveals additional degradation mechanisms that amplified supply chain stress. Continuous high-tempo operations under field conditions created engine wear patterns that exceeded design specifications, resulting in increased fuel consumption and reduced operational reliability. Cold weather operations imposed additional thermal stresses that accelerated mechanical failures while increasing fuel requirements for engine warming and personnel survival. These effects were predictable from engineering analysis, but were not adequately incorporated into supply planning calculations. The geometry of supply line extension created unavoidable constraints that could not be overcome through tactical adaptation or operational efficiency. Linear advance distances created geometric increases in transport requirements due to the two-dimensional area that supply operations had to cover. Security requirements for supply route protection created additional geometric constraints as convoy escort requirements grew exponentially with route length and threat density. These geometric effects operated independently of organizational efficiency or tactical success. Relief valve analysis of Wehrmacht logistics reveals that emergency procedures designed to manage supply disruptions actually accelerated overall system failure. Fuel rationing protocols reduced immediate consumption while creating operational constraints that reduced tactical effectiveness. Maintenance interval extensions preserved parts inventory while increasing vehicle breakdown rates. Supply priority systems maintained critical operations while creating cascading failures in secondary systems. The evidence component analysis shows systematic failure in captured resource integration that eliminated projected supply contributions from occupied territories. Soviet scorched earth policies destroyed approximately 80% of fuel stocks before German capture, eliminating the resource base that Wehrmacht planning had assumed would support extended operations. Transportation infrastructure suffered systematic destruction that required extensive reconstruction, consuming German engineering resources while providing minimal immediate supply capacity. Rupture disk equivalent analysis identifies the specific failure points where Wehrmacht supply capacity exceeded design limits. Transport convoy operations reached maximum sustainable frequency when vehicles operated on continuous duty cycles without adequate maintenance downtime. Fuel delivery systems exceeded capacity when storage requirements approached maximum safe inventory levels. Personnel systems reached exhaustion when replacement rates fell below attrition levels across extended operational periods. The drainline temperature equivalent in Wehrmacht logistics manifested as the gradual depletion of strategic reserves that had initially masked supply shortfalls. Fuel stockpiles that had been accumulated for sustained operations were consumed to cover daily shortfalls between delivery capacity and consumption requirements. Vehicle parts inventory diminished as maintenance requirements exceeded replacement procurement. Personnel reserves declined as combat and logistics attrition exceeded replacement training capacity. Why system indicators remained correct while becoming diagnostically misleading reflects the fundamental design assumptions embedded in Wehrmacht logistics doctrine. Measurement systems were optimized for tactical operations within sustainable supply networks, assumptions that became invalid under conditions of extreme geographic extension. Supply indicators that accurately reflected immediate delivery success failed to convey cumulative capacity degradation that would soon eliminate operational sustainability. The feedback loop mechanism demonstrates how actions based on false operational picture worsened underlying supply chain dynamics. Tactical advances undertaken to shorten supply lines by capturing forward supply bases actually extended supply requirements by expanding territorial control obligations. Resource conservation measures that appeared to extend operational capacity actually reduced system resilience by eliminating reserve margins required for crisis response. Efficiency improvements that optimized immediate operations accelerated long-term capacity depletion. Administrative decision patterns reveal how Wehrmacht logistics management consistently interpreted supply challenges as temporary adaptation problems rather than fundamental capacity limitations. Each successful daily operation reinforced confidence in supply system adaptability, while cumulative degradation continued below crisis recognition thresholds. The institutional bias toward tactical optimization prevented recognition that the operational problem required strategic adjustment rather than efficiency improvement. The mathematical progression toward inevitable failure followed predictable patterns that could have been identified through comprehensive supply chain modeling. Transport capacity utilization rates approaching 100% eliminated operational flexibility required for crisis response. Inventory turnover rates exceeding sustainable replacement created accelerating stock depletion. Personnel utilization approaching maximum sustainable levels reduced system resilience while increasing failure probability. Recovery stabilization became mathematically impossible once daily consumption requirements permanently exceeded maximum delivery capacity under optimal conditions. No combination of efficiency improvements, captured resource integration, or operational modifications could restore positive supply balance once this threshold was exceeded. The Wehrmacht had created operational commitments that required resource consumption rates beyond the capacity of their supply infrastructure to sustain. Wehrmacht attempts to stabilize supply operations during late 1941 and early 1942 created additional systemic vulnerabilities, while temporarily masking the fundamental unsustainability of extended operations. Recovery actions that appeared to restore operational effectiveness actually introduced new constraints and failure modes that amplified long-term strategic vulnerability. The apparent success of these stabilization measures delayed recognition of approaching comprehensive collapse while consuming critical system reserves required for sustainable operations. The primary stabilization attempt focused on supply line consolidation through operational pause and defensive position establishment. Army Group Center halted offensive operations in December 1941, ostensibly to consolidate territorial gains and restore supply line efficiency. This operational adjustment temporarily reduced fuel consumption requirements while enabling convoy optimization and route improvement. Initial results appeared promising, with fuel delivery margins improving from critical to sustainable levels and vehicle availability increasing through concentrated maintenance efforts. However, consolidation operations introduced new resource requirements that partially offset supply line efficiency gains. Defensive position construction consumed engineering resources and transportation capacity that could otherwise support supply operations. Winter survival preparations required additional fuel allocations for heating and equipment winterization. Personnel concentration in defensive positions created logistical inefficiencies that increased per capita supply requirements compared to dispersed offensive operations. The stabilization effectiveness remained uncertain due to fundamental measurement limitations that prevented accurate assessment of supply chain health. Improved delivery margins appeared to indicate successful adaptation, while actually reflecting reduced operational tempo rather than restored capacity. Vehicle availability statistics improved through concentrated maintenance efforts that consumed accumulated parts inventory, creating future sustainability challenges that current indicators could not detect. Fuel consumption reductions reflected tactical constraints rather than resolved supply capacity. Secondary crisis mechanisms emerged from interactions between winter weather conditions and supply chain vulnerabilities that had been manageable under previous operational circumstances. Cold weather operations imposed exponential increases in fuel requirements for vehicle operation and personnel survival that exceeded available delivery capacity. Fuel quality degradation under extreme temperature conditions reduced engine efficiency while increasing breakdown rates. Road surface deterioration prevented optimal convoy operations, reducing transport efficiency when maximum capacity was critically needed. Hydrogen accumulation equivalent analysis reveals how seemingly minor efficiency losses cascaded into major operational constraints. Increased fuel consumption for winter operations created cumulative shortfalls that required consumption of strategic reserves. Reduced transport efficiency due to weather conditions created delivery delays that accumulated into systemic backup throughout the supply network. Personnel attrition from cold exposure created manning shortages that reduced operational capability across all system functions. The cavitation equivalent in Wehrmacht logistics manifested as the breakdown of supply scheduling reliability under marginal operational conditions. Supply convoys operating near capacity limits lost schedule predictability when minor delays created cascading disruptions throughout the delivery network. Forward units operating with minimal inventory reserves suffered immediate operational degradation when delivery schedules were disrupted. The loss of schedule reliability eliminated operational planning predictability, forcing reactive rather than proactive resource management. Loss of circulation verification became apparent when Wehrmacht logistics commanders lost reliable visibility into actual supply flow dynamics across extended operational networks. Communication delays and reporting limitations prevented real-time monitoring of supply status across distributed operations. Local adaptation measures, while maintaining immediate operational capability, created system-wide inefficiencies that could not be detected through aggregate reporting. The resulting loss of system visibility prevented effective resource allocation and crisis response. Containment atmosphere constraints emerged as the geographic scope of Wehrmacht operations exceeded the capacity of available security forces to protect extended supply lines. Partisan activity and irregular warfare created additional security requirements that consumed combat effectiveness while reducing transport efficiency. Supply route protection required diversion of tactical units from primary missions, creating cascading capability reductions across operational functions. The security burden created a spiral where expanded operations required increased security that further reduced available operational capacity. Decision-making transformation from procedure following to expert judgment under uncertainty reflected the breakdown of Wehrmacht logistics doctrine under conditions beyond design specifications. Standard supply procedures assumed predictable demand patterns and reliable delivery capacity, assumptions that no longer held under extended winter operations. Field commanders were forced to make resource allocation decisions based on incomplete information and uncertain supply projections. This shift to judgment-based decision-making introduced additional variability and potential for error into logistics operations. The engineering calculation summary approach to supply management revealed systematic gaps between theoretical capacity and practical operational capability. Planning calculations based on optimal convoy efficiency and minimal security overhead proved unrealistic under actual field conditions. Weather impact assessments underestimated fuel consumption increases and transport efficiency reductions. Personnel productivity models failed to account for degradation under extended stress and extreme environmental conditions. Post-event operational test results demonstrated that Wehrmacht stabilization measures had preserved immediate tactical capability, while consuming strategic reserves required for sustained operations. Vehicle maintenance programs that improved immediate availability rates depleted parts inventory that could not be replaced, due to production limitations and transport constraints. Fuel conservation measures that extended operational duration reduced tactical effectiveness and increased vulnerability to enemy action. Personnel rotation policies that maintained unit effectiveness consumed replacement capacity that exceeded training and recruitment rates. Why system stability remained uncertain despite apparent recovery reflects fundamental limitations in Wehrmacht logistics assessment capability. Measurement systems that tracked immediate operational indicators could not detect cumulative degradation in strategic capacity. Tactical success metrics did not incorporate sustainability analysis that could project future operational capability. The institutional focus on immediate problem-solving prevented comprehensive evaluation of system-wide resource depletion. The operational testing framework revealed discrepancies between reported stabilization success and actual system capacity. Units that reported restored operational readiness actually operated with reduced capability margins that eliminated resilience against future disruptions. Supply systems that appeared to function normally actually operated beyond sustainable utilization rates that guaranteed future breakdown. Personnel systems that maintained adequate strength levels consumed replacement capacity faster than sustainable recruitment could provide. What could not be known during stabilization attempts was the extent to which temporary measures were consuming irreplaceable strategic capacity. Vehicle maintenance that restored immediate operational availability required parts that could not be replaced due to supply line limitations. Fuel conservation that maintained current operations depleted reserves required for future tactical flexibility. Personnel utilization that preserved unit effectiveness exceeded sustainable rotation rates that could prevent long-term capability degradation. Forensic requirements for later analysis became apparent as Wehrmacht stabilization measures created complex interactions between immediate tactical needs and strategic sustainability that could only be evaluated through comprehensive post-operational assessment. The success or failure of recovery attempts could not be determined through contemporary operational indicators that lacked strategic perspective. Only comprehensive analysis of resource consumption patterns, capacity utilization rates, and system degradation trends could reveal whether stabilization efforts had restored sustainable operations or merely delayed inevitable collapse. The uncertainty regarding actual system stability during this period reflected fundamental limitations in real-time logistics assessment under extreme operational conditions. Wehrmacht commanders lacked the analytical tools and measurement frameworks required to distinguish between genuine recovery and temporary stabilization measures that consumed critical reserves. This assessment limitation prevented recognition that apparent operational recovery was actually accelerating strategic capacity depletion through unsustainable resource consumption patterns. The transition toward comprehensive breakdown became inevitable once stabilization attempts had consumed the strategic reserves required to maintain system resilience under stress. Recovery measures that appeared successful in the short term created long-term vulnerabilities that exceeded the Wehrmacht's capacity to address through available resources and organizational capabilities. Post-war analysis of Wehrmacht logistics collapse revealed the comprehensive scope of supply chain breakdown that had been concealed by tactical adaptation measures and organizational reporting biases during the operational period. Detailed examination of captured German logistics records, combined with systematic analysis of abandoned equipment distributions and resource consumption patterns, provided definitive evidence that the Blitz-enabled expansion had exceeded sustainable capacity limits by mathematically predictable margins that contemporary assessments had failed to recognize. Forensic confirmation of supply chain collapse came through multiple independent measurement approaches that converged on consistent conclusions about the Wehrmacht's operational sustainability. Vehicle abandonment patterns across the Eastern Front demonstrated geometric increases in breakdown rates, correlating directly with distance from German supply bases. Fuel consumption records revealed systematic shortfalls between delivery capacity and operational requirements that had been masked through strategic reserve depletion. Personnel strength reports showed attrition rates that exceeded replacement capacity by margins that guaranteed long-term capability degradation. Physical inspection of abandoned Blitz vehicles revealed maintenance degradation patterns that confirmed the predicted relationship between extended operations and system reliability. Engine wear analysis showed operation beyond design specifications, with cylinder scoring and bearing failures consistent with inadequate lubrication and extended maintenance intervals. Transmission failures displayed patterns characteristic of continuous high-stress operation without adequate cooling periods. Suspension component analysis revealed stress fractures and fatigue failures consistent with overloading and poor road surface conditions. The distribution of abandoned vehicles provided geographic evidence for the relationship between supply line extension and operational sustainability. vehicle density decreased exponentially with distance from German supply bases, following mathematical patterns that confirmed transport capacity limitations rather than tactical decisions as the primary constraint on operational depth. The highest concentrations of abandoned equipment occurred at geographic points corresponding to maximum sustainable supply reach under optimal conditions. Captured German logistics documentation revealed systematic discrepancies between reported operational capability and actual supply chain status that had enabled continued optimistic assessment despite approaching breakdown. Daily strength reports that indicated adequate vehicle availability failed to account for maintenance backlogs that threatened future operational capacity. Fuel delivery reports that confirmed successful supply operations did not include analysis of consumption trends that exceeded sustainable delivery rates. Personnel reports that showed acceptable manning levels omitted attrition projections that indicated approaching manpower exhaustion. Inspection results confirmed that Wehrmacht logistics measurements had provided accurate tactical information while systematically concealing strategic vulnerability. Vehicle readiness statistics that reported acceptable availability rates did not account for reduced operational capability due to deferred maintenance and parts shortages. Supply delivery data that indicated successful mission accomplishment failed to incorporate trend analysis that revealed accelerating capacity degradation. These measurement limitations had prevented recognition of approaching comprehensive failure until collapse became inevitable. The forensic analysis resolved the question of what was feared versus what was found regarding Wehrmacht logistics sustainability. Contemporary German assessments had recognized supply challenges but consistently underestimated their severity and systematic nature. Post-war analysis revealed that supply chain breakdown was more comprehensive and occurred earlier than German command recognition, confirming that operational collapse was mathematically inevitable given the resource requirements of extended operations and available supply capacity. Investigation findings became the foundation for concrete changes in military logistics doctrine that addressed the systematic vulnerabilities revealed by Wehrmacht experience. Direct state indication requirements replaced indirect signal interpretation in supply chain monitoring systems. Modern logistics doctrine mandates real-time resource flow analysis rather than periodic inventory assessment to prevent accumulation of hidden capacity degradation. Contemporary supply planning requires mathematical modeling of transport capacity limitations rather than assuming scalable expansion based on tactical requirements. Alarm management and prioritization systems were redesigned to address the information overload and diagnostic delays that had prevented effective Wehrmacht crisis recognition. Modern logistics command systems integrate multiple data streams to provide comprehensive system health assessment rather than compartmentalized functional reporting. Priority algorithms ensure that strategic sustainability indicators receive appropriate command attention even when tactical operations appear successful. Simulator training scope expansion addressed the training limitations that had left Wehrmacht officers unprepared for supply chain crisis management. Contemporary military education includes extensive analysis of logistics sustainability under extended operations, preparing commanders to recognize capacity limitations before they become operationally critical. Training exercises specifically address scenarios where tactical success creates strategic vulnerability through resource depletion. Human factors integration into military logistics management reflected lessons learned from Wehrmacht organizational biases that had enabled systematic misassessment of operational sustainability. Modern doctrine requires independent logistics assessment that operates outside tactical command structures to prevent optimistic bias from influencing supply chain analysis. Decision-making processes include mandatory consideration of strategic sustainability constraints before authorizing extended operations. Regulatory oversight improvements addressed the institutional failures that had prevented recognition of Wehrmacht logistics vulnerability despite clear mathematical indicators of approaching breakdown. Contemporary military organizations require comprehensive resource sustainability assessment before authorizing operations beyond established supply capacity. Independent analysis requirements prevent institutional bias from influencing logistics planning and crisis recognition. The measurable impact of Wehrmacht logistics failure extended beyond immediate tactical consequences to influence strategic capability for the remainder of World War II. Vehicle losses. During the 1941-1942 breakdown eliminated experienced logistics personnel and reliable transport equipment that could not be replaced due to production constraints and material shortages. The loss of accumulated spare parts inventory created maintenance capability reductions that affected all subsequent operations. Personnel attrition from supply chain crisis exceeded replacement capacity and reduced logistics expertise across all operational theaters. Psychological and public perception dynamics resulting from supply chain collapse influenced German military morale and strategic decision-making throughout the war. Recognition that the Wehrmacht's most successful operational phase had created irreversible strategic vulnerability undermined confidence in military leadership and strategic planning. The contrast between tactical success and strategic failure created organizational cognitive dissonance that affected decision-making quality in subsequent operations. The systemic lessons from Wehrmacht logistics collapse addressed fundamental assumptions about the relationship between tactical capability and strategic sustainability that had enabled the Blitz-driven overextension. Modern military doctrine recognizes supply chain capacity as a constraint that must influence operational planning rather than a support function that should adapt to tactical requirements. Strategic planning requires mathematical analysis of logistics sustainability rather than assuming that operational success validates continued expansion. The evidence confirmed that the Wehrmacht logistics system had not failed because of human carelessness, equipment inadequacy, or tactical incompetence. The failure resulted from systematic misunderstanding of the exponential relationship between territorial expansion and resource requirements, enabled by measurement systems that provided accurate tactical information while concealing strategic vulnerability. The information structure and embedded assumptions had made wrong decisions appear rational to competent decision-makers, operating with the best available contemporary knowledge. Contemporary logistics doctrine incorporates the fundamental recognition that engineering excellence and tactical success can create conditions for strategic disaster when operational patterns exceed the carrying capacity of supporting infrastructure. The Wehrmacht's experience demonstrated that system strength could become system vulnerability when organizational assumptions and measurement frameworks prevented recognition of approaching sustainability limits. The forensic loop back to the original contradiction confirms that the Opel Blitz system operated exactly as designed while enabling operational patterns that exceeded sustainable capacity. The vehicle's reliability and the Wehrmacht's tactical competence created confidence in logistics doctrine that proved fundamentally flawed under conditions of extreme geographic extension. The system provided information that was technically correct and strategically misleading, making rational decisions that led inevitably to comprehensive operational failure.